If you're new to soldering, then the things I'm going to talk about in this video will greatly help you achieve better solder joints and make soldering more enjoyable. I will show you step by step what techniques to use, what tools to use, how to prevent your soldering iron turning into this, and the best way to correct mistakes to get you started with soldering. When I was new to soldering, I often had the problem that the solder would melt but not stick to the components. This is because there is a layer of oxide on the components or a circuit board pad. When metal is exposed to air, oxides can form on unprotected surfaces. These do not conduct current and solder is not adhered to it. This is a wire which has been stripped a while ago. It is covered with oxide. You can see that it is darker than this exposed wire I just stripped and does not hold solder as well as the freshly stripped wire. You can remove oxide mechanically by scrubbing it off, but a better method is removing it chemically with flux. Flux is used to clean the surface and also helps wetting the solder, which makes it flow better. There are several forms of flux to remove oxide like paste and pencils. However, most solder already has a core with flux. This flux has a lower melting point, so it removes the oxide before the solder melts. The solder on this tip comes from solder that has a flux core. However, the flux is already evaporated, so it doesn't remove the oxide from the wire, preventing the solder to stick to the wire. This is why using solder with flux is not enough, but also the correct technique is needed to create a good solder joint. There are actually two ways of mounting components. Through-hole technology, where the legs of the components go through the circuit board, and surface mount technology, where the components are soldered on top of the circuit board. This method is for through-hole technology. Before making a connection with solder, we first need to make a mechanically stable connection. This means that we place the components in such a way that we can easily solder them. A PCB holder works amazing for this. A third hand can be used for soldering wires. Legs can be bent to hold components in place. Components with shorter legs can be held in place with Kapton tape. Kapton tape is tape that can withstand high temperatures. I recommend lead-free solder with a core that contains flux, also called a rosin core. Thin solder makes controlling the amount of used solder easier. I recommend 1 mm for through-hole components and 0.5 mm for surface mount components. For lead-free solder, a temperature of 320 to 350 degrees would be recommended. However, if you are planning on using solder with lead, a temperature of 300 to 330 degrees is recommended. When your soldering iron is at your desired temperature, make sure to clean the tip. This removes excess solder and flux residue. This can be done with brass wool or a wet soldering sponge. I recommend using brass wool because a soldering sponge will cool down the soldering tip, which can slow down your work. Then add some solder to the tip. This prevents oxides from forming on the tip but also helps with heat transfer. Then clean the tip again. Solder on the tip increases the contact surface, which helps with better heat transfer. However, most of the time there is too much solder on the tip after tinning, so that is why cleaning it after tinning often works better. Hold the tip against the circuit board pad and the leg of the component at the same time. You do this for about a second. Then feed the solder to the connection. You don't want to press the solder against the tip. You want the heat from the pad and the leg to melt the solder. Don't press hard, let the heat do its work. Then take away the solder, but keep the soldering iron in place for about a second before removing the iron as well. Then clean your tip. If you are soldering wires, make sure to hold the tip against the top or side of the wires. Holding it against the bottom causes solder to collect at the tip instead of the wire. A desoldering pump or desoldering braid can be used to remove solder. My favorite method is using a desoldering braid. It is held against the solder and the iron is used to heat it up. The braid will absorb the tin until you are able to remove the component. If it is not absorbing the tin as well as you would like, you could add some flux to the braid. The braid can then be cut to remove the saturated parts. Removing components can be difficult if you directly apply a soldering iron. Adding some flux or solder with flux will help remove oxide and increase heat transfer to make it easier. If you have to desolder larger amounts of components, I would recommend getting a desoldering station. These heat up the tin and suck it away, allowing you to work faster. The one thing that made soldering easier and more enjoyable for me was investing in a soldering iron with an active tip. A passive soldering iron has a metal object which is placed over a heating rod. A soldering iron with an active tip has an integrated heat element and temperature sensor for better heat transfer while soldering, causing the solder to melt way quicker. It also decreases the time for the iron to heat up. Choosing the correct tip also makes soldering easier. We more often choose a tip that is too small than one that's too large. Larger tips transfer more heat, making it easier to solder. A chisel tip would be best for most of your work. The fumes which form while soldering are actually from the flux, not the tin or lead which are melting. A fume extractor helps to ventilate these fumes, which is especially pleasant when soldering for longer periods of time. Also, if you work with electrostatic discharge sensitive components, don't forget to use an earthing band and mat to reduce the risk of damaging your components. When you invest in a nice soldering station, you don't want your soldering iron to turn into this. This is oxidation. You want to prevent this, not fix it afterwards. The best way to prevent it is to always keep your soldering tip tinned. When you're done soldering, tin your tip one last time before storing it. The tin will prevent oxidation. Using a temperature that is too high will also increase oxidation on your soldering iron. If there is not enough heat transfer, use a larger tip and make sure you tin the tip before soldering. If you really need to clean a tip, you can use one of these tip tinners. However, preventing is better because tip tinners can damage the coating of the tip. And that's it. I hope that these things will help you with your soldering projects. Don't forget to subscribe for more content like this. And if you have any further questions, please let me know. If you're new to soldering, make sure to check out this video because I'm sure that it will help you become better at soldering.